laser. What is thulium fiber? You need to forget this cavity with the mirror that we described before with holmium. Forget about the crystals and forget about holmium. The thulium fiber is a fiber, and this fiber is not the surgical fiber. This is the fiber who will produce the laser light. Again, this is not a cavity like holmium, this is just a fiber, a very long one, 10 to 30 meters long. But it's a very thin fiber. And the center of the fiber is 10 microns. So it's really, really small. And the center of this fiber is completely transparent. And it's doped by thulium elements. So it means that you take this thulium element and you pollute the center of the fiber with the thulium. So now you have a long fiber with thulium element in the middle. That's what we call a thulium fiber laser. To activate this laser, we are not using a flash lamp like holmium, the krypton light. We are using diode lasers. And it's possible to connect multiple diode lasers to activate this system. This is actually the thulium fiber element. At the end of this fiber, you still connect surgical laser fiber. And with this element, it's possible to connect very small fiber, up to 50 microns. You remember, for holmium, the smallest one actually is 200. But with the thulium fiber, it will be possible to connect very small fiber, 50 microns. And now that's what you produce. Look at the effect into the saline. As you can see, it's still a Moses effect. But again, it's a completely different Moses effect. It's plenty of bubbles, as you can see. It's almost continuous. It's not continuous, it's still pulsed. But you see the speed, much, much faster than holmium. If you look at the spectrum, thulium fiber is very close to holmium. It's also in the infrared spectrum, so it's not visible. But now the spectrum is 1940 nanometers. So again, very close to holmium. But if you look in terms of absorption in water, you see that thulium fiber is at the maximum peak of absorption for the water. It's 4 times more absorbed than holmium. Just the comparison, holmium versus thulium. 2 different technologies, 2 different effects, as you can see. And again, just to see the view, this is holmium, and you see this bubble who expand and collapse regularly, and the thulium fiber. They are also producing bubbles who increase and collapse, but much more than holmium YAG. Thulium is pulsed like holmium, so it means that we have to produce to fix the parameters in terms of energy, frequency, and pulse duration. It's like for holmium. The only question is actually that we don't really know which parameter is the best. Even we have some ideas, and you have seen this morning, we gave some recommendations, but we have still to evaluate which parameter actually the best. If you compare the 2 technology, that's the table. You can see the pulse energy, the difference, the maximum peak power. It's a very important parameter, the peak power. And the peak power for the thulium is 500 watts. So it's completely efficient with 500. For holmium, it's from 2,000 to 10,000 watts. And as you know, this is regularly too much. The peak power is mainly responsible for the retropulsions. I'm used to say that we cannot compare the specification really regarding the thulium and the holmium. It's like if you would like to compare two sport cars. You would like to compare an Aston Martin V12 and with a Ferrari V8. It's two different engines, okay? Very difficult to compare in terms of technology. You can compare the outcomes in terms of speed, but you cannot really compare the engines. If you would like to compare, you should select a V8 Aston Martin with a V8 Ferrari, and now you can compare the technology. Thulium and holmium, it's something similar. It's two different technologies. You can compare the holmium from Luminis and the holmium from Dornier, but it's difficult to compare actually the thulium with holmium in terms of technology. So let's go for the outcomes. What can we do with thulium? We have seen a nice demo this morning. This endoscopic view that you can see is coming from the lab. You see we are using the litho view to record all the videos on the left, and you see the external view. This is a stone, relatively soft. We are using 50 millijoules, as we did this morning, much more frequency because this is the lab, so we have no restriction. We use 1000 Hertz, so it's 50 watts with a relatively short pulse duration, 0.2, and you see the effect. In few seconds, we completely dust a stone of 1 centimeter. 1 centimeter means 500 cubic millimeter. And you see the external view. It's really efficient and really fast, producing very small pieces. Coming from the lab, again, if we compare stone ablation, holmium versus thulium fiber is always superior to holmium. Even we change the parameters, since the first pulse, thulium is always superior to holmium. If we compare the dust productions in the same period of time with the same stones, we produce 3 times more dust than holmium, even when we are using the MOSIS technology. What do we call dust? As you know, there is no clear definition. What is your own definition of dust? Some people said less than 1 millimeter, it's okay. Less than ½ millimeter. In our lab, the definition is less than 250 microns, particles. So when we evaluate in this